All right, more motorcycle content out here in my shop this afternoon. I know my last few projects have been focused on the DRZ, but it's winter here in the Pacific Northwest and the weather sucks. It's been raining for weeks, so I haven't been able to do any flying out of the Astoria airport and kind of limited time out in the woods with the drones. So I'm occupying my spare time with projects out here in the shop on the motorcycle. All right, in the last few videos I replaced the headlight with this Morimoto LED sealed beam light right here. And we installed a tail tidy, got rid of the black plastic fender back here and put a LED tail light in here. We did the 3x3 mod on the airbox and a JD jet kit on the carburetor. So what's left? Well, what's left is that there's no USB power supply or other power socket up here for me to plug cameras or my helmet intercom or phone or anything into. So we're going to add that today. I spent a little bit of time in Fusion 360 again and 3D printed this nice elegant solution for mounting a power socket. Now this basically bolts into place right underneath the factory speedometer, just like this. I'll have to move some cables around. Then it has this hole right here for a standard 12 volt power socket, and this is the power socket we're going to use. I've picked up, I don't know, quite a few of these, 6 or 7 of them. I've got one installed on the Ducati, and I've installed a couple on some other vehicles that I have. I really like these because they have a digital voltmeter, standard USB-A with QC 3.0, and then 2 USB-C ports that are PD compliant, so I can fast charge my phone or iPad or anything that takes that PD protocol with USB-C. So this is like 3 USB chargers in one. And I really like them. Like I said, I've got them in my other vehicles and they work great for me. So that takes care of mounting this thing. Where are we going to tap in our power from? Now there's some considerations. On a bike like this, it does make a limited amount of power. I mean, the alternator assembly, the rotor and the stator can only produce just so much power. So it's not like we have unlimited power to work with. And also the electrical system on this bike is fused with just one main power fuse back at the battery. So all the circuits are not individually fused. So if I'm going to tap into something up here, I need to make sure that I'm not drawing more current than the plugs, the wires, the key switch, all that stuff is designed to carry. Now fortunately, this thing right here with all 3 USB ports running at their maximum capacity is going to draw 58 watts. We'll round that up to 60 watts. So 60 watts divided by 12 volts is 5 amps. So under the worst case conditions, this thing right here is going to add an additional 5 amps of draw to whatever circuit that I put it in. Now in reality, it's only going to ever draw that much power if I happen to have 3 devices plugged in that are fully utilizing the PD and QC charge protocols. I can almost guarantee that's never going to happen, because even if I do plug a PD compliant device in here, it only utilizes the quick charge for a certain portion of the battery charge cycle. Same thing with QC. It's just never going to be drawing 5 amps. But we're going to make sure that whatever it is that we tap into is capable of 5 amps, just in case I hit that 1 in a million shot of actually drawing full power through this thing. So I've done a little bit of testing in here. I've got this big clump of connectors right here and some other odds and ends. This thing has 5 volts on it for some reason. Don't know what that goes to. But this green connector right here is going to be super handy for this project. This brown wire right here carries power back to the taillight. And this is what I'm going to tap into. The reason I like this circuit is that I've already changed the taillight from the stock incandescent one, which drew around 2.5 amps, to an LED one, which draws 0.11. So I've essentially freed up almost 2 amps already on this circuit. So adding this thing to it is only going to potentially add up to 3 more amps from stock, and I guarantee that adding 3 amps is not going to hurt anything in this circuit. So this is a great one to tap into. The second advantage is that this is only hot when the key is in the on or the park position, and then it's off when the key is in the off position. Now the reason I like that is that I'll essentially never forget and leave this thing turned on. I mean, the key's got to be in it with it in park for this thing to be live. Now I could run this directly to the battery, however there would be some parasitic draw, and the motorcycle batteries just aren't very big. So this solution's much better, and I can make up a piggyback plug to actually plug into this right here, so I won't even have to cut any of the bike's factory wiring. Basically, I'll make up a male and a female jumper to go in between here, and I'll tap in wiring out of this where this brown wire goes in. So let's get to it. Now, this 3D printed piece right here has a stiffening rib in here, and I did print it in ABS, so it should withstand some sunlight without getting soft, temperature swings, things like that. It's pretty strong. I doubt I'm going to have any issues with it. I think it looks pretty good. It set the this surface is just about flush with the front of the speedometer assembly here. That should work nicely. Well, I mentioned I was going to build kind of a tap connector to tap into that tail light circuit. I got this connector assortment from Amazon. It was super cheap, it was like 16 bucks or something like that. And the quality may not quite be the best, but it's got a lot of the connectors in it that the bike uses. Like this is the tail light connector right here, and there's some other spots that use these. So anyway, let's use this 4 conductor housing right here and get to work building our tap connector. Well, our little jumper assembly is made up. Basically the wires just go straight across here, and it allows me to essentially do a 90-degree bend to tap into the 2 factory plugs, and then it gives me this lead right here, which is where I'm going to pull my 12 volts from. Make sure that this thing's actually going to work before I solder it together here. Should work. Let's make sure my tail lights and headlights still work. We're all wired up. See what happens when we turn the key. All right. You guys noticed I wired up this little plug right here too. I'm also going to be installing a phone cradle right here where I can that'll hold my phone, and that cradle has a wireless charging option. So we're going to plug this in, and that's going to be what what this goes to for most of the time. But I will have the option of unplugging this and using this to pull 12 volts for something else. That phone holder, I got a really cool ball mount that'll take the place of one of these bar clamp bolts right here. So I'm going to go get that out. We'll get that thing installed and plug it in and make sure it charges my phone. These are little 1-inch ball mounts. I've got a couple of these for a couple of my bikes. They work really good. Basically, the socket head cap screw just goes right through here, and it takes the place of whatever fastener that you removed. In my case, it's for the bar clamp. Of course, I could get clamps to go on this crossbar instead of doing this, but this is a much more secure method. This is the phone holder I got. It holds you know, all the corners of the phone nice and secure. It's spring loaded, and it uses the standard 1-inch ball mount on the back. And I got it with this, it's like an anti-theft type clamp. That way some thief isn't going to just make away with this, at least not easily, when I leave my bike parked somewhere. Yeah, there we go. Fast wireless charging. It's a pretty, I don't know, tidy installation. There isn't a whole lot of stuff flopping around. I don't know if that's where I want to keep the phone, but it's definitely staying there. It's not going anywhere, so releasing it's easy enough. That pretty much wraps up this project. Really was pretty easy. I think it's a nice, neat installation. Not a lot of extra wires going everywhere, and it's easily removable. Well, thanks for sticking with me through another motorcycle project. I hope you guys like this kind of stuff. As always, I'll put links in the video description to the parts and materials that I used for the project. And I'll probably also go ahead and make the bracket that I 3D printed available on Thingiverse, so there should be a link to that in the video description as well. Thanks again for following along. See you guys on the next one.